Good morning, students. In the last class, we discussed about the chemical properties of amines up to carbon-amine reaction. Today, we are going to discuss about the another chemical property, that is reaction with nitrous acid. Reaction with nitrous acid. Example for this nitrous acid is NaNO2. Okay, students, what happens when this amines reacts with nitrous acid? Okay, so first consider amines, that is R and H2 compounds reacts with what? Nitrous acid. NaNO2 in presence of HCl. Okay, NaNO2 in presence of reacts with nitrous acetate, that is, this is sodium nitrous acid, this one is nitrous acid, that is HNO2, nitric acid HNO3. Okay, so HNO3 is called as what? Nitric acid, because based on this oxidation state we are going to calculate. Here the oxidation state of nitrogen is +3. Here the oxidation state of nitrogen is +5. Okay. So if copper is in +1 state, copper is in +2 state, this is called as cuprous. This one is called as cupric. So whatever the element is there, for example, Fe+2 is there, Fe+3 is there. Fe+2 is called as ferrous. Fe+3 is called as ferric. So the metals which are in higher oxidation state are ends with Ic, and the lower oxidation state ends with OUS. Okay, so this one is nitrous acid. So this amines reacts with this nitrous acid in presence of NaNO2 and HCl. NaNO2 and HCl. Okay, so they form R NH3 plus Cl minus. What it is? Ammonium salts. Okay, so which is further on hydrolysis gives ROH plus N2 plus H2O with the liberation of HCl. Understand? So first what happens when the amines reacts with this HNO2, that is nitrous acid, they gives ammonium salts, that is quaternary ammonium salts. Understand? So students, here the one thing you have to, so this one is N2. One thing you have to remember is, so here instead of R you take CH3 and H2. Instead of R you take CH3 and H2 plus HNO2 in presence of NaNO2 and HCl. Okay, so what is the product formula? Instead of CHR you take CH3 and H2 Cl. This is plus, this is minus. Okay, so followed by hydrolysis. The HCl will remove, then it form. Instead of R, we are taking here, that is CH3OH plus N2 plus H2O. So students, the overall reaction, only the thing we are going to change is the R group. Okay, so here, instead of this, if you consider a benzene ring with NH2 group, this is aniline. So when this aniline reacts with nitrous acid in presence of NaNO2 plus HCl, they form N2Cl minus. This is plus, this is minus. Here aromatic amines, what they form? N2Cl minus. Here they form NH2Cl minus. Okay. So this N2 means, I'll write here, the structure also written as N triple bond N plus Cl minus. Okay, so this one is nitrous acid. Okay, so when this aniline reacts with nitrous acid in presence of Na2 from 0 to 5 degrees Celsius, remember, very cold condition. So then they form this type of compound. Here N double bond N is there, that is called as azole group. N double bond N is there, that is called azole. So this one is called as benzene diazonium chloride. This one is called as what? Benzene diazonium chloride. And this complete reaction is called as Sand-Meyer's reaction. Sand-Meyer's reaction. So this you are going to study in the next diazonium salt. Okay, in the diazonium salt, diazotization test is there. Okay, so this is NH2 means aromatic amine. When aliphatic amine forms, reacts with nitrous acid followed by hydrolysis forms alcohols. Okay, when these type of compounds, that is aromatic amines, reacts with nitrous acid, they form azo compounds. Okay, so students, further if it is react with cuprous chloride or anything else, right here further reaction is if it is reacts by cuprous chloride, okay, then they form Cl plus N2. They form chlorobenzene. Okay, this is just an example I am giving. What happens further? Here further it upon hydrolysis it gives alcohol. Further if they are treated with cuprous salts, they give azole. Sorry, benzene trichlor. Then chlorobenzene. Okay, monosubstituted chlorobenzene. Understand? So you have to remember only this much. When the aromatic amines reacts with HNO2 in presence of NaNO2 and HCl, the condition is 0 to 5 degrees Celsius. In a cold condition, they form benzene diazonium chloride. Okay, so this is reaction with nitrous acid. Next one is reaction with, okay, aryl sulfonyl chloride. Reaction with aryl sulfonyl chloride. So this is also called as benzene sulfonyl chloride. Okay, students, I'll write the structure of benzene sulfonyl chloride. So this is the benzene ring, to which S double bond O, Cl is attached. This is benzene sulfonyl chloride. Okay, so this reagent is called as Ensberg reagent. Very important reagent, because this is a reagent used to distinguish primary amine, secondary amine and tertiary amine. Okay, Ensberg reagent. This reagent used to distinguish between primary, secondary and tertiary amine. So how they will react? So listen, primary amine and write first. Primary amine means R, N, H, H. If one carbon atom is attached to nitrogen, then it is said to be primary. Okay. Next, secondary amine. That is R, N, R, H. Two R groups are attached to nitrogen, then it is said to be what? Secondary amine. So next one is tertiary amine. Tertiary amine means R, N, R, R. Okay, students. The reaction we are going to write now is how this primary, secondary, and tertiary amines reacts with benzene sulfonyl chloride. So right here, this is the benzene ring. Write it in a reverse manner. This is double bond O, Cl. Correct? Next, here also you take benzene sulfonyl chloride. So here also you take benzene sulfonyl chloride, because as I told you, this is the distinguished test between benzene and this. So distinguished test between primary, secondary, and tertiary amines. Okay, so students, here what happens? HCl is removed. Okay, so if we remove HCl, what is the product we get? Here R is there, N is there, to the N, H is attached. HCl is removed means double bond O, the benzene ring. Correct? Next, here also HCl will remove. The remaining is R, single bond N, here R. So HCl is removed means next is sulfur, double bond O with the benzene ring. Okay, so students, as I told you, here to remove the Cl atom we require H. Here all are R groups. Okay, so these R groups are identical, whether they are identical or non-identical. Then also they didn't react with this benzene sulfonyl chloride because of the absence of hydrogen atom. So because of the absence of hydrogen atom, this tertiary amine doesn't react with this benzene sulfonyl chloride. So this reaction cannot take place. Are you right here? Here it is no reaction. Okay, so this is the distinguishes. So how they distinguishes primary, secondary, and tertiary means? So listen, students. If this compound is dissolved in NaOH solution, alkali. Why? Because so listen, here lone pair of electrons are there. Right? Here double bond is there. So these are involved in resonance. So these electrons may shift here, these electrons shift here. Okay. Again, these electrons either shift here. Here, all the double bond and single bond compounds are there. So the lone pair of electrons involved in what? Resonance. So if they are involved in resonance, this is less basic. This hydrogen become highly acidic, less basic. Highly acidic means easily soluble in base. Okay, so students, if you had due to the formation of the hydrogen bond, as this hydrogen is highly acidic, so then what happens? It is soluble in NaOH. Okay, next, here there is no hydrogen atom. Correct? Here there is no hydrogen atom means it is insoluble in NaOH. Okay, here there is no reaction. So this is white precipitate, this is also white precipitate. Okay, how the distinguished takes place? So listen, when the amines, given amine, we don't know whether it is primary, secondary, or tertiary. So we are taking, in a one test tube, we are taking amine. We don't know which type of amine it is. So we are adding this sulfonyl chloride, aryl sulfonyl chloride. So in a test tube, if we add the benzene sulfonyl chloride, we will get white color precipitate. Okay. That white color precipitate, upon adding NaOH, if it is soluble, then it is primary amine. If it is insoluble, then it is secondary amine. Okay. If there is no precipitate is formed, then it is tertiary amine. Okay. This is one of the best method to distinguish primary, secondary, and tertiary amine. This is very important for 1 marks, and the structure of Ensberg is also important for 1 mark. What is Ensberg reagent and what is the use of that Ensberg reagent? Ensberg reagent means benzene sulfonyl chloride. What is this use? It is used to distinguish between the amines. Okay. So there is a distinguish test for that, students. How we have to write? Okay. So in the test column, you take amine plus Ensberg reagent. This is the test column. Okay. Next, observation. Okay. So first, white precipitate which is soluble in NaOH. If it is soluble in NaOH, what is the inference or result? It is primary amine. Okay. Next, second, white PPT which is insoluble in NaOH. That means secondary amine. Okay. Third one, no white precipitate, then it is tertiary amine. So this is the distinguished test for different types of amine. Here we are taking amine plus enzymes for reagent, then we will get white precipitate soluble in NaOH primary, white precipitate which is insoluble in NaOH secondary, and there is no white precipitate, that is tertiary. Okay. So one thing you have to remember here, students, consider this. So students, listen. Here I am taking the compound C2H7N. It is a amine. C2H7N, molecular formula is there. That means this is a amine. Okay. So plus Ensberg reagent. Understand? So if it gives white precipitate which is soluble in NaOH, means that is primary amine. Primary amine means for the one nitrogen, one carbon is attached, that is CH2, CH3. You count, 2 carbon atoms are there, 3 plus 2 plus 2, 7 hydrogen atom is there. When it is white precipitate which is soluble in NaOH. So if the same reaction is there, C2H7N, that is the amine, we don't know which type of amine it is. When we have this Ensberg reagent, if white precipitate is formed but it is insoluble in NaOH. So that means what? Here nitrogen is there, that is insoluble in NaOH means it is attached to 2 carbon atom because it is a secondary amine. So then this is CH3, CH3, NH. Formula remains same, that is C2H7N. Understand? If there is no reaction, that must be a tertiary amine. But here only 2 carbon atom is there. There may be a possibility only primary as well as secondary. Okay? So this is reaction with sulfonyl chloride. Next one is students, that is electrophilic substitution reaction of amines, especially aniline. Next one is electrophilic substitution reactions. Okay, students. So in the last lesson, this electrophilic substitution reactions, we are considering only the aromatic amines. Okay. So in the last class, I read the resonance structure first. So this benzene ring is there with NH2. So here lone pair electrons are there. These lone pair electrons involved in the resonance. Correct. So next we will get this electron comes here means double bond NH2 plus, this one is minus. Similarly, if we do students the resonance structure from here, here and here, you will get minus charge. Argon para position, we get what? Minus charge. Means the respective product, here minus charge means the species attached must be positive. Here minus charge is there, the bond or the incoming species must be plus to balance this reaction. Okay, plus means that is electrophile. Understand? Due to the involvement of these lone pair electrons in the resonance, the hydrogen of this becomes what? Acidic. Okay, due to that acidic means they easily displace. So acidic means they possess the minus charge. Okay, it easily donates H plus ion. Acid means what? Which the species which give H plus ion. So it becomes acidic means it easily donates H plus ion. Understand? So that means here minus will left. Are you getting my point? Here in all the H will be there, correct? So here, due to the involvement of this lone pair of electron in the resonance, these hydrogen become acidic. So acidic means the acid is a substance which easily donate H plus ion. So it donate H plus ion means minus sign will left here. So H plus is the electrophile, correct? So to replace, to balance this minus charge, we have positive species called as electrophiles. So by replacing H plus by the respective electrophile called as electrophilic substitution reaction. So here this electrophilic substitution reaction takes place in ortho and para position only. Understand? So this reaction takes place in ortho as well as para position. Meta position is unaffected. Understand? So because in the resonance we are getting minus charge at ortho and para positions only. So based on this we are going to conduct following reactions. So first one is bromination. So first one is bromination. So students, when this aniline this aniline reacts with bromine water, aqueous solution, that is bromine water. Then it forms at which position PR may be attached? Ortho para. Okay. So if here we are taking only this aqueous solution of Br2, that is bromine water, without any reagent here, then we will get tri-substituted aniline. This is tribromo aniline. Okay, tribromo aniline. If you have to write the position, this is 1, 2, 3, 4. 1, 2, 3, 4, 5. So you have to write 1, 3, 5 tribromo aniline. Okay. So students, but we want mono-substituted substances, not tri-substituted. We want what? Mono-substituted. Then, so to get mono-substituted product, we have to protect NH2 group. Okay, so listen students, why this tri-substituted product came means because the lone pair of electron present on this nitrogen involved in the resonance creates minus charge at ortho, para and ortho position. So because of the reason involvement of this lone pair of electrons in the resonance, we are getting tri-substituted compound. Okay, but we want mono-substituted product means we have to protect NH2 group. That means NH2 group shouldn't involve in resonance. Here lone pair of electrons and this NH2 group is there, correct? This is protected by addition of any other reagents. Okay, if it is protected means these lone pair electrons never involved in this resonance. Understand? To protect this NH2 group, so we are adding acetic anhydride in presence of pyridine as a solvent. Understand students? So we are adding CH3, CO twice O, pyridine as a solvent. So here we get benzene ring is there. Okay, so listen, here NH2 is there, correct? So this is written as students, I write here CH3, CO, CH3, C double one O, O, C double one O, CH3. This is the structure of this. CH3, CO twice, O. Okay? So here, this will break. Understand? So here NH2 is there. So one H reacts with this form CH3, C double one O, OH. That is acetic acid. Here O is there, breaking will take place. H from this nitrogen reacts with this form CH3, COOH. Okay, remaining is this one C double one to CH3 that is attached to this nitrogen. Understand? This group attached to nitrogen, one nitrogen combines with remaining of this group form acetic acid. Understand? So next here, then you will read this Br2 in presence of CH3COOH. Okay, it reacts with Br2 in presence of CH3COOH. You will get here. This is protected means It is NH, double bond O, CH3. So students, this is a bulkier group. There is no possibility of formation of this ortho product. Why? Because this is a bulkier group. Here another Br is there. The distance between these two is very less. Understand? So they are nearer to each other, means repulsion takes place. Understand? Even though the ortho product form, then also it is in minor. So that's why here it refers para product. Understand? So next what you have to do, you do hydrolysis. Are treated with water or any acid. So H plus and OH minus ion is there. Then you will get here students. Here this bond will get breaks. Correct? So then it forms. Here Br is there. Then NH bond breaks means it reacts with one hydrogen to form NH2, and this reacts with OH forms CH3, COOH. Understand? So this is the reaction. When the bromination of this aniline takes place in two steps, if we are using only the bromine water, then we will get tri-substituted bromoaniline. So what is the reason for that? The lone pair of electron present in this amine is involved in resonance, forms a negative charge on ortho and para position. Okay, that's why they give tribromoaniline. If we want a mono-substituted compound, then we have to protect the NH2 group involved in the resonance. Okay, how it is involved? How it is treated? Sorry. How it is protected means by reacting with acetic anhydride. Okay, so NH2 group is protected by this acetic anhydride, then they form this type of complex. Amide they will form. Okay, so here what happens students, by the formation of this, these lone pair of electrons, instead of involved in this resonance, they involved in the resonance with this carbon atom. Means this involved here, this involved here. That means lone pair of electrons is not available for this benzene ring to exhibit resonance. Understand? So once it is protected, then it is treated with bromine water in presence of acetic acid. Then they form NHC double bond O CH3. That is our para substituted bromoaniline. Okay. So why it is para substituted? Because ortho position is nearer to this group. This group is already a bulkier group. There is a steric hindrance, means repulsion between these two positions. That's why if ortho group is formed also, ortho product is formed also, that is unstable. The repulsion takes place, hence the para product is major. Understand? So followed by hydrolysis, again it will regain its functional group NH2 along with the liberation or formation of the product CH3COH. So this is called as para bromoaniline. So this is the product we got. Understand? So all the bromination, whether it is bromination, nitration or another sulfonation, okay? All the reactions taking place in this manner only. You may take chlorination also. Instead of bromination, if we are taking chlorine here, means that will also give trichloroaniline. So to protect mono-substituted compound, we have to protect this NH2 group. Understand? So this is bromination. Two types of reactions are there. So students, this type of reactions are very, very important for 2 marks. They will ask directly in the examination what happens to the aniline or what is the product formed when aniline reacts with bromine water. Bromine water they mention means we get 1,4, 1,3, 5 tribromoaniline. If they mention what is the product formed when the aniline reacts with bromine in presence of acetic acid. Bromine in presence of acetic acid means it gives para-bromoaniline. That is the product you are going to write. This type of questions they are going to ask for 2 marks. You have to remember that. Understand? So the next one is nitration. Next one is students, that is nitration. Okay, so what is this nitration? Means the aniline reacts with, I take directly reagent to take nitrating mixture, that is HNO3 and H2SO4 at 288 Kelvin. When this aniline reacts with what? Nitrating mixture. This is called as nitrating mixture. HNO3 and H2SO4. Okay. Then what it forms? So it forms three different compounds. And right first, what are those three different compounds? Questions? So they form nitro substituted compound, okay, meta substituted NO2 and para substituted NO2. They form three different forms. Then we are, instead of bromination, we are doing what? Nitration. Nitration means what is the condition? HNO3 in presence of H2SO4 at 288 Kelvin, and also acetic acid also there. There may be a presence of acetic acid or not. Nitration will take place. After protecting this NH2, nitration will take place. So then what happens? It forms NO2 here. That is para substituted subproduct. Okay, so followed by hydrolysis, it gives NO2, that is para nitro aniline. Understand, students? What is the change difference in that bromination and nitration is only the reaction mixture. Okay, in the first case also, listen, without protecting this NH2 group, if we do bromination, we will get tri-substituted product, artho, para, artho, tribromo. Here also, without protecting NH2 group, we are getting three different products, artho, para, meta. Okay, to get mono substituted, we have to protect this group. Everything is same until the product is. After protecting this group, bromination if we do, we will get para-bromoaniline. Nitration we will do, we will get para-nitroaniline. Chlorination if we do, we will get para-chloroaniline. Understand? Sulfonation if we do, we will get para-sulfonyl-aniline. Whatever the reaction we conduct here, our acetic anhydride you may consider, we will get para-methyl aniline. Okay, we don't bother about what is the reaction taking place here, students. The only thing here is they form NO2. So they give majorly para product. Understand? So this is the reaction. So similarly, in the same way, you do it for sulfonation. Okay, So this is homework for you people. You do it for sulfonation. So in the next class, I will explain sulfonation and also diazonium salts. That will end up this chapter. Only one topic left. That is reaction. That is sulfonation takes place in the same manner. Here you take sulfuric acid. Okay. Here in the place of NH2, they give tri-substituted here and here like this. Okay, SO3H will attach here. So if you protect this, if you are doing sulfonation here instead of NO2 group, here SO3H group will attach. Okay, you do it yourself. In the next class, I will explain again. Okay, along with that, I will explain the diazonium salts that will complete the chapter. Okay, thank you.